So I noticed some people had some trouble with this, so we're going to run through it, and we'll go from there. This is the lesson objective. Define atomic number. So that tells you need to know what the atomic number is and how it's used. All right, the atomic number for an element indicates the number of blank. The definition of atomic number is that it is the number of protons. Okay, so the atomic number is the number of protons. That's the definition. Atoms can be classified as a particular element based on the number of protons. And again, the number of protons is the atomic number. Okay, so if you know the atomic number, you know how many protons are in the nucleus, but you also know how or which element it is. In theory, I mean, who knows? But if aliens are real and aliens came and talked to us, obviously they'd speak a different language. They wouldn't speak English. But if they somehow communicated, 4 protons, we would know that they were talking about beryllium. They'd have a different name for it. They'd have a different name for protons, but we would know. We would figure it out. All right. The number of positively charged protons must equal the number of negatively charged electrons. That is true. In a neutral atom, the protons equal the electrons. Okay. All atoms of the same element must have the same atomic number. Okay. If they're the same element, they have the same atomic number, because the atomic number is the number of protons, and the number of protons determines what element it is. Atomic number for nickel, just look at the periodic table. Okay, scandium has blank protons in its nucleus. You look at the periodic table, you find scandium, you find the atomic number. Okay, so for example, you could go to ptable.com. Okay, scandium is right here. Okay, so its atomic number is 21, and if the atomic number is 21, it has 21 protons in the nucleus. Yeah, that's all there is to it. All right, I'm going to skip over most of these. I think most people did okay on these. So with this one, you had to fill in the missing information. So for example, chromium has 24 protons. Well, if it has 24 protons and it's neutral, okay, then that means if it has 24 protons, it has 24 electrons. Okay? If the atomic mass is 51, then we're going to say 51 minus 24. Okay? And that gives us the number of neutrons. So what would that be? 27. So 27 neutrons in this isotope. To get the atomic number, we just look at the protons. If the protons is 24, the atomic number is 24. Okay? So with just the mass and the protons, you can figure out the other 3. Okay? If you have the atomic number and the mass, you can figure out the other 3. Because the atomic number is the same as the protons. And since this is a neutral atom, protons and electrons are the same. So this would be 14. This would be 14. Okay. If the number of protons is 14 and the mass is 30, then 30 minus 14 would be 16 neutrons. Okay, so you've got to think through it, and you've got to know the vocabulary. Okay, but it's doable. Understand how isotopes differ from one another and be able to designate them by various methods. All right, so remember, isotopes are the same element, but they have different numbers of neutrons. Okay, that's how they differ from one another. They have different numbers of neutrons. Okay, we can write it like this one. So this is the chemical symbol for iodine. It's an I, capital I. And then you have 131. So that is the atomic mass or the mass number of this specific isotope. So this is correct. Okay. All right. Be able to calculate the average atomic mass of an element. Now, I think this was harder for some people. So like we had a problem here and you had to work this out. So let's take a look at that on the board. Okay. So the way you're going to do this is you're going to say 7.59% times 6.015. All right, and then that's going to give you a number. All right, so 7 point. Now, looking at my calculator here, I do not have a percent. Okay, so instead of doing 7.59, I'm going to do 0.0759. Okay, in order to go from percent to decimal, you just move the decimal 2 spaces to the left. All right, so let's see here. We're going to say 0.0759 times 6.015. All right, and that gives me 0.4565, we'll say. All right, then we're going to say 0.9241, because it's a percent that we're changing to a decimal, times 7.016. All right, now if 92% of it has a mass of 7, then I would expect the final answer to be closer to 7 than 6. But let's keep working it out here. So we're going to say, first of all, I'm going to clear everything. 0.9241 times 7.016 and equals, and that gives me 6.4835. All right. The final step is we're going to take those two numbers and we're going to add them together. 0.4565 plus 6.4835. And so, let's see, plus, oops, I thought it would give me the answer, but I guess not. All right. 0.4565 plus 6.4835 equals 6.94. So 6.94 would be the average atomic mass of lithium based on the data that we have. And notice my prediction is fairly close. It's a lot closer to 7 than 6. And if we wanted to check, we could go back to our old friend ptable.com, and we see that the listed isotope or average atomic mass is 6.94. Okay. Now again, if we look for isotopes, there are a lot more than 2 isotopes of lithium. Okay, some have some pretty hefty masses. Like there's lithium 12, so it has 3 protons and 9 neutrons. Okay, but again, some of these are very rare, and some of them only exist for a very short time. All right, so the most missed question is all atoms of a given element are identical, and the answer is false because of isotopes. Okay, now Chemically, do they all act the same if they're the same element? Yes. But they're not identical because they could have different numbers of neutrons, making them isotopes. All right? So I hope this helps.